The thing, whenever we, as I told you regarding the multi-threading, the benefit what it provides, right? So it does not come with only benefits. Everything has a pros and cons, and even multi-threading too has some problems when we use the multi-threading. Just suppose, just one example, what I had given last example. So you have opened a joint account with your friend or with your family member or your spouse or someone, and what do is that you went to the bank and you got both of you got two cards, right? Two different cards to withdraw the money, and you both went to the ATM and trying to withdraw the money. Now what happens, right? Suppose it can be situations where you both try to swipe the card at the same time. Suppose such situations happens, and the money, what it should be deducted from a common balance, right? Because both of you, your amount balance will be at one place only, at one central location, right? In one particular DB. So what happens, right? Suppose one of the person got the money, and before the ATM could have notified the bank server that okay, XYZ person has withdrew the money, so reduce the balance from 5,000 to 1,000, because 4,000 has been withdrawn, and the second person which was withdrawing, that time he or she had seen the balance was 5,000. By the time she or he has been put the ATM number and withdraw the money, so his or her friend or whoever is a joint account holder that withdrew the money. So yeah, and this person did not get the notification that someone withdrew the money. Now what will happen, right? At this position you will see that okay, your balance is insufficient, you will get the insufficient message or something like that, right? I mean, so what actually happens, right? The problem, what happens, there are many problems which can be occur because of multi-threading. So one thing is something like update and delete issues. What actually happens because of this? One thread T1 is updating a file, writing something, and T2 is reading that file, and T3 again writing something to it. What will happen? Suppose these three threads works on a one particular file, abc.txt file, and one is reading, one is writing. What problem it could lead to is that one is updating and one is reading. So suppose I am writing abc, def and all these things, right? And this guy is reading. Before it completes writing, the finished writing, this guy is trying to read it and it reads the wrong data, right? And this also, if both the things are writing, right? So suppose one is writing A, B, C, D, E, F, and X, Y, Z is supposed to be written by this, and then it might occur that T1 is again writing to this location, right? So this kind of problem might occur when you use the multi-threading. So not only this, there is a very good example I had shown in the last session. I will not repeat fully because it's totally on YouTube. You can go and see that. I will not waste time in that. So it's already I had explained, just little bit overview I'll give you anyway. But the problem what it can lead to is at the concurrency problem. So same time if you try to access the same resource by different threads, it will create the problem. So what example I gave right last time is we have an account class which is holding just ignore this line, I'm commenting out right now, I'm commenting out this and commenting out this. Okay, don't assume these codes are there. So class account, and there is a balance of 5,000 rupees is there, and then there is a method as a withdraw int amount, and after that what actually I'm doing. So this account class is supposed to do an operation of something like withdraw. So bank provides you a facility that you can withdraw the certain amount of money. So int amount is that's what here it is, and your balance is suppose 5,000 rupees initial balance you have, and this entire is your account balance application. So your bank account provides two things: you can put an initial balance, and then you can withdraw, keep withdrawing certain amount of money. Now there is a certain logic here what I have written, that whenever you want to withdraw the money, what are the things that bank will look into that, right? So first thing it will see is that whether you have the sufficient balance or not. So your bank has 5,000 rupees, and you're trying to withdraw the money about 100 rupees or 500 rupees or 10,000 or something. How it will check? It will check that whether it's greater than or not, or the difference is greater than 0 or not. So either it should be greater than or equals to 0. So what actually is there? Suppose I'm trying to withdraw 10,000 rupees, right? So though my balance is 5,000, I'm trying to withdraw the 10,000. So balance is my 5,000 minus 10,000, which will be minus 5,000, and difference will become minus 5,000. This condition will never get satisfied, so you cannot withdraw the money, right? Otherwise it will throw some exception here. Suppose you are withdrawing 1,000 rupees, so 5,000 minus 1,000, so difference is 4,000. So it will say, okay, difference is 4,000, that is perfectly fine. So reduce the balance now, or let them withdraw the money. So balance minus amount, so 5,000 minus 1,000, so now it's 4,900, and balance will be updated by that thread 4,900, and it will display that, okay, withdrew balance, and the amount is 4,000 or 1,000, and balance is 4,900 by that particular thread. Whoever is going to create, whatever thread is going to call this withdraw method. And I have created a thread class here. You can write it in a separate file as well. A class withdrawer. This is like a withdrawer task or thread, I would say. Extending thread class, as usual. If you extend thread, it will create a thread. And I am, putting a account object. So it's kind of authorization, or you can say authentication or authorization. It is that it is holding the account, just like holding a passbook or certain kind of credentials or some kind of document which you can say that you are you have the privilege or you have the authority to withdraw the money. So it just serves something like that only. So whatever this account is, I am making a member of this class, withdrawer class, so that using this account object, that can call the withdraw method here. And in extending thread, that means we need to write a run method. That is from where the thread starts, as you already know. And account dot withdraw 100 rupees, I'm telling, okay, withdraw 100 rupees. Now in the main app, what exactly I'm doing is I'm creating one account object, the main common object, and then I'm creating 5 threads. As you can see, 1 to 5 threads I will be creating. So withdrawer user thread equals to new withdrawer. I am setting that account. I'm putting the same account to everybody. So as I told you, it's a joint hold account. So whatever the object I have created, I am setting that same account to everybody, and then I'm starting that thread and putting the account number as account holder 1, account holder 2, account holder 3, because this i's value will keep on changing, and that's how we print it. Today is Monday, right? Okay, fine. So user thread dot set name, so account holder 1 to 5, so total there are 5 account holders, and there is a one account with balance 5,000 rupees, and you try to withdraw the money by 100 rupees each. So what should be the balance at the end of the transactions? If all the transactions happens, right, start of the thread, so we are submitting it to the thread scheduler, and once they run it 5 times, it is going to be run, this account dot withdraw by 5 threads, and 5 times it will go to this particular place. So what will be the balance at the end of the all these 5 withdraws? So what should be the balance when the last person withdraws? Come on, it's very easy, right? You can't guess what it will be. It's very simple mathematics, right? You have 5,000 rupees in balance in account. You have five account holders. Each account holder is withdrawing 100 rupees. What will be the balance after 5 people withdraws their money? 4,500, right? It's very simple mathematics, no? Okay, so it should be 4,500 because 5 people are there, all are withdrawing their money, and it should be 4,500. But unfortunately, it won't be because of certain kind of issues. I don't know what it is printing. Okay, yeah. Okay, so it's perfectly fine right here, but it will not be in a moment. Yeah, here it goes. The first person who withdrew the 100 rupees, the balance it is showing 4,700, which is totally incorrect. What it should be? What it should be? Come on, speak up, because I think it's a very simple thing. Yeah, it should be 4,900, right? I mean, 100 rupees you are withdrawing should be 4,900. It's showing 4,700. Again, if you are withdrawing 100, it should be 4,800. It is showing 4,500, and then suddenly it has increased. I'm not even adding the money, but even it is increasing, right? It should have been 4,900, 800, 700, 4,600, and 4,500. At the end of this person, whoever is the last withdrawer, that time the balance should be 4,500, which is wrong, right? So this is the problem. What is happening here? Why it is happening? The reason is, just think about here. When you create 5 threads, 5 withdrawer threads you have created, you have submitted it to the thread scheduler. All 5 threads are there in the thread scheduler, and all 5 are trying to run the run method. And as I told you, this run method will be called by the thread scheduler, not the thread, and you cannot control this one. So thread will try to run it in their own way. So see, as first time the thread account holder 3 has got the chance, right? So suppose account holder 3 has got the chance, and it is calling this account withdraw method. So withdraw with 100 rupees. It came here and it took 100 rupees here, and it is checking whether the difference is balance minus 100. So what will be 5,000 minus 100? Difference is 4,900, and it came here. It is checking, okay, difference is 4,900, which is perfectly fine for me. Come here, balance. What it did, balance equals to balance minus amount it did. So finally now balance is 4,900 here, right? So for the first time for account holder, this could have been the situation where the balance is 4,900, and before it could have been printed this line. Okay, the thread has been removed from the thread scheduler, and the thread scheduler it has been removed. That means it will remember that this line has been executed. I need to print from this line. Okay, and when it did, that time the balance was 4,900, correct? And so the problem what it will be is, it will come here, and the second thread, suppose account holder 5 has come, and it got the chance here, and it will come here. It will check here again. The balance is 4,900. Now it will deduct. It will be 4,000. Difference will be 4,800. 4,800 here it will come, and here it updates that it's a 4,800. It prints out that okay, it's a 4,800, and it comes back perfectly fine, and it shows the balance is 4800, which is totally incorrect, because it should have been the first, when whoever is withdrawing the first money, it should be the balance should be the 4900. Now the problem what will come, maybe this is a one problem. Second is, suppose again threads account holder 3 got chance, and it will see that okay, I had already deducted the money, I just need to intimate to the server, I just need to let know to the server that okay, I withdrew the money, and it will say okay, update balance as 4900, because last time when he had visited, that time this amount was 4900, though the balance is now 4800, right? These kind of situations will occur when you use multi-threading, when you use the common area for all the multi-threading concepts. So these things are called the critical section, where the work should be done at a time. Other things you should do wherever the read things are there, only you need to read. There you should not use the the concept locking or something. So how you can resolve this problem? So last time I had in last session I had told about the solution, but I did not explain it. So what do you think the solution could be here? How can you first of all tell me, did you understand the problem, what is happening here? Did you understand that problem, what is happening here? Okay, you can speak up, because I don't know, I mean, this message is very small, it is coming here. Okay, Shweta, it's fine, right? Oh, Shweta, you there? Okay, fine. Okay, great. Uh, so how we can overcome this problem? I mean, how we can resolve this issue? Is my speaker is okay? Oh, you guys are okay, fine. So how we can resolve this problem, right? The one thing what we can do is we can do the work in sequential, right? One at a time. Now if we do one at a time, it will be again going back to the same thing, that okay, one by one we are doing, one by one we are doing, right? So again, what will be the purpose of using multi-threading then, right? There is a concept of locking. We can lock the particular segment of code where you want to access only one thread at a time. And only one thread at a time means that thread once enter into that section, until and unless it finishes its work, no other thread cannot enter into that thread. So it's like of kind of a room with a single key with 5 people or 5 account holder. Only one person can go inside the room. That is the first rule. Second rule, to go into the room they need the key, and only one person can hold the key. Third rule is, once a person goes inside the room, they cannot come out of it until and unless it finishes the work. Even if it comes out of the room without finishing the work, it will not give the key to anybody by saying that okay, I haven't finished my work and thread scheduler has been removed from that room. I'm not going to give that key to anybody until and unless I go back again and finish my work. So these 4 things what happens here, these 4 things what you can do to avoid the problems. So what is that key? That key is nothing but, in Java there is a concept of monitor. A monitor is nothing but it's a simple object. Any object, you in Java everything is object, whatever you see, right? It's a class, and you see account AC equals to new account, that AC will become the object, or object equals to new object. Just like here, object is a class, you're creating object, lock equals to new object, or you just simply write C, or you simply write monitor or anything. So it's always good to write some significant name. So object lock equals to new object, you're creating an object, and just make this lock, this as this resource, this memory location, or this value as the key to enter a critical section. How do you define the critical section? To define the critical section is, you need to write a keyword as known as a name as a synchronized, and in bracket you provide the that particular object. So I'm creating an object, object lock equals to new object. I'm making it final so that nobody can change it, because this object should remain the same for all the threads. So what I'm doing here, I'm telling, okay, final object lock equal to new object. It's doing nothing. It's doing only that it is creating one object as a lock, named as a lock, and it's making it final so that suppose tomorrow someone does some clever thing and they try to assign something here, they won't be able to do that, because if they try to change it, the value of, if they change it, something like, it's like changing the lock. So you cannot do that. You cannot again assign the value to it. It will say it's a final and you are not supposed to do that. Why it's not giving any problem? What actually I was explaining is how we can we can achieve this locking, right? So the critical sections, how you define is that you write synchronized keyword, you pass this object, whatever the object you are creating, and then I'll see that later, no problem. Then lock you do, and then you put a bracket and you write all the codes, what are the causing the problem, what are the things you want to make it uh, critical sections, you want to keep it in inside that, and these codes you can write inside the parenthesis, and you can tell that okay, this part is locked, whatever the this blue part is showing, right? This part is locked by the object lock. Now how actually it works, right? If I run it now, what is the problem happening here? One second. Drawer. Okay, yeah. What is this? Okay. Okay, yeah, there's some little bug introduced. So if I run it now, it will be perfectly fine, and whatever times I run it, right? As you can see, 4,900, 800, 700, 600, and 500. It's working fantastically, no problem. Now the issue is, how it is getting resolved is, you have 5 threads, right? What you are creating, T1, T2, T3, T4, T5. Okay, and this is your critical section. What I'll say, critical sections, that means where you are doing that logic, right? Whatever the logic you are doing, and to get into this critical sections, you need a key, and that key is your lock object. Okay, so whoever holds this key can enter into this critical section and do their work. Now suppose T3 got selected by the thread scheduler, right? So thread scheduler call the run method, and run method calls the that withdraw method, and withdraw method is nothing but the entire, that is the critical section, right? So this is the overall the things which is happening here, as you can see here, withdraw method, right? So this is my critical sections, which, and the lock is done on this object right now here. So suppose T3 got the first option, first thing to get into that, and once it reaches to that point here, synchronized here on lock, so what it will do is that it will request the JVM the first time when the thread comes here, right? So whoever, suppose thread 3 has come here. So thread 3, when it will see that okay, there is a gate here, there is a door here, and it's been locked here. Okay, so first thread, when it comes, it's locked, and it sees that it's locked, and it needs the key to uh, it needs the key to enter into the house. Now the problem what will happen is it cannot enter into this section until and unless it gets the key to that particular room. So what it will do, that thread is request the JVM that okay, give me the lock object, this lock object. I want to get the lock and to enter into this section. So that thread can only enter into this section until unless it gets the lock. So JVM will they will have their own algorithms, and there are table where it will see that okay, if this lock is already with some thread, then it will say okay, I cannot give you the lock, please wait until unless other threads happens, right? So for the first time when it comes, there is no other user thread is always running. This is the first thread which is trying to get the lock, and obviously the lock is available, the key is available. I'm telling lock and key together, so don't confuse with that. It's just think about as a key. So key is available to that particular lock, and the thread T3 will enter into this particular section, and it is doing its work. It found out the difference. It came here, found the difference greater than 0, and it did the just like the old scenario I told you. It checked this balance minus amount it did, and before it could have printed this one, what did thread scheduler do is it removed this thread from this running state. It moved it to the runnable state. As soon as it's moved, this thread T3 will be moved with their key only. So thread T3 will be holding that particular lock, or you can say as a key. So it will be locked by thread T. And what it does is thread should say, okay, it's more than enough time, you took long time. Let's give T2 as a chance to go there. Once key 2 arrives here, it sees okay, oh, there is a lock here. I need to get the lock on this particular section to do some work, as it's a prohibited area, and I need a key to enter that. It will request the JVM, okay, give me the key to get inside the room. JVM will say, oh, hey, let me check that whether it's occupied by something else. If it is, then I will not be able to give you. You need to wait here. You need to be in blocked state, and that's what I was talking about when I was explaining you the states of a thread. This is called the blocked state, or you can say the waiting state. It's a waiting state. It will go that particular thread T2. T2 will go into waiting state, and JVM will see okay, lock is with T3. So JVM will say to the thread scheduler, see, T2 is waiting for the lock, but it's with T3 because you removed T3 before it could have finished its works. So give the chance to T3 to finish the work so that it can proceed with that and release the lock, and I can get the lock out of it. So T3 will move back to the thread running state, and it had finished his work here. It will start printing here. As there is no thread has been landed to this particular section till now, so obviously the amount will be 1000 and the balance has to be 4900. And once it comes out of this, the T2 will get the lock, and then again it will do the work. Suppose again T2 also gets removed from here after this section only. Again it will keep their lock with that, and if other threads try to enter into that, they cannot enter into this section until and unless the lock is provided by the previous lock holder. So this is how it resolves the problem. Let me know, tell me if you haven't understand this point, because it's a very important to understand this. It's a locking and synchronization part is very critical in Java programming. Whatever web server you see or any kind of web application you see, it has to be the multi-threading. If you think about web applications, it has to be multi-threading. You can make your standalone application as non-threaded application, but your web application has to be the multi-threaded. And that's why multi-threading is a part of advanced Java. It's not a part of core Java. It's advanced Java. So let me know if you have any question. Understood, everybody?
Yes.
Okay, great. Yeah. Rahul, I think you haven't, attended many of the classes, so please go through those videos. It will be, helpful for you. Maybe a few things might be going over your head. I don't know. I maybe, but go through the videos. Few videos are there, and the extra classes what I will be taking, right? You can go through. Okay. I think already shared you the link, right? Okay, good. Yeah. So no question in multi-threading. I thought a lot of question will be coming, but it's okay. If you have understand, it's great. Good. So this is all about multi-threading. I mean, I don't see much of a problem here. If you have understand this synchronization context, there is one more way to do this. This is called the uh, what I say, this kind of synchronization or this kind of locking is called the segment based. It's like, a part of code what you are doing, and this is the best practice to do it. That's why I started with that. Another way to do is that you can, lock on the method level only. You can directly lock this particular withdraw method only. So disadvantage of this is, suppose there are a few things like, okay, printing hello Java, and it has nothing to do with any calculation, any updation, any operations or anything, just merely the printing statement, right? It doesn't require any kind of locking. And if I make the withdraw method synchronized, and if I put a lock on entire method, this will also get locked, which is not a good idea to do that. And that's why it's always good to use the segment based, or the, you can say, this is called the uh, method level, and yeah, segment based, right? So method level, how you can do that, instead of writing this statement like this, you remove all this stuff from here. You simply write public void synchronized. What is the problem? Public synchronized. Okay, public synchronized void withdraw method. That's it. You don't have to do anything else. I think it's easy to use, but difficult to maintain the code. I mean, it's a performance hampering. You are not supposed to use everywhere. You can use it, synchronized keyword, because it kills the concept of multi-threading. If you are using the synchronization, it is killing the purpose of using multi-threading. It's a very, very costly keyword. I would say the most costliest. I would say costliest keyword in the Java. So use it very, wherever it's needed, really important, where you do you think that it can lead to instability of your application or some kind of problem, then only use it. Otherwise, never ever use the synchronization keyword. So because, as you know that, right, I mean, the holding, the waiting state and all these things, right? And there is a very big problem which can lead to this, is called the deadlock. I'll just, after this, I'll explain you what is deadlock. Deadlock is a situation where one thread is waiting for another thread to get the lock. Another thread is waiting for the second to get the lock. It's something like, depending on each other. If you would have studied the, I'll just tell you the syntax wise only. No need to write the program, because I cannot show you the deadlock situations. It's a very rare, and if it comes, it's nightmare to solve it. So what happens, right? Suppose class A is there, and you are writing something like, you have a string s1 equal to new string, and string s2 equals to new string. You are creating two object, and you are creating a two thread as well, t1 and t2. Okay, you have created t1 and t2, and suppose in your run method, inside the run method, what you are doing is, you're keeping a lock. First you are doing that a lock on, so synchronization on str1 or s1. Then you are trying to get the lock on s2. Okay. And after that you are doing some operation, you are printing, or you are doing something, system.out.println and hello, and the t2. Okay, the same logic, suppose you are writing here, you are calling some other method where the locking first happens on s2 and then it happens on s1. Suppose there is a such kind of situation, scenario is there. Okay, so what will happen here is uh, S1 and S2, there are two objects, and the first thread which enters here, right, it says, okay, get a lock on synchronization lock on S1, and then try to get the lock on S2. But as soon as it try to get the lock on S2, before that, suppose S1, the thread T2 got the hold of S2, and it is trying to get the lock on S1. But it sees that this S1 is locked by the T1 here, so it has to wait. So T1 is waiting to get the lock on S1, and T1 is waiting to get the lock on S2, which is held by this one. It's called a circular waiting. One is waiting for another, another is waiting for this one. This kind of scenario can never ever come out of this application, and it will always lead into the deadlock. So it will, your application will go into infinite waiting. Your thread will keep on waiting forever. It will think that, okay, once this guy will release the lock, I'll get the lock and finish my work. This will say, okay, get release of the lock and come out of this. This scenario is called the deadlock scenario. Okay, and to come over this is only one way, is that restart the application, and then again, if your program is badly written like this, you frequently might end up in going into the deadlock. So whenever it comes to multi-threading synchronization, it's really very much expertise you need to use the synchronization, how to use judiciously, where to use, where not to use, in what scenario you need to use. So it's more about experience rather than just a syntax and writing the code, running it. So try to go through more examples, learn about these things, and yeah. So this is all about multi-threading, what I would say from my end. If you guys have any questions, you can tell me later. uh, I want to cover one more topic today, and then maybe tomorrow I will cover this SQL section, so that I can start JDBC, that Java database, where you can connect to the database and get the data from database and all these things, right? So are you guys practicing? I mean, in Eclipse, you trying program writing, doing things, something? Any issues you are facing or anything? Okay, good. Okay, yeah. So there are many other things what you can do with the yeah, I understand this one. You can go through the videos are there. So I think if you will have any issues, we can discuss. And also weekends, as we have taken the class, right, we can take the sessions on weekends, so it will be fine. I think whatever I explained, right, it's already there in videos. So if you can try there, right, whatever the issues will come, we can check it. Okay. But practicing, try to write the program, try to run it, because if you keep just attending the sessions and doing nothing, right, it won't be helpful, it won't be helpful much. So just focus on that also, it will be good. uh, Multi-threading, as I told you, there are two ways through which you can do. uh, there are certain methods which you can use for multi-threadings. There are certain things you would like to have a control over, like when to pause a thread for some time, when to make it to release the relinquish the lock. You can make a force a thread. You can increase the priority as well. Priority is something like, as I told you, if you run 5 threads here, right? So it's not guaranteed, but you can try. I mean, there are a few things which can you do, something like here. Though I am writing the application like, see, I1, right? So according to the fair chances, right, account holder 1 should get the first chance to get to the balance, right? But yeah, here it got it, but after that account holder 2 should have got. But as you can see, account holder 4 had got the chance, then 3, then somewhere 2, right? uh, there are a few ways where you can enhance the priority of a thread, that okay, execute this thread. You can request the thread scheduler, that's all you can do. And the thread priority varies between 1 to 10 value, if I'm not wrong. Let me check that. So thread has their priorities, and you can set that thread. So let me see, class printer class extends thread. Okay, public void run there thread dot current thread dot get name. Okay, so I'm just printing, which thread is getting printed. See, it doesn't have any, guarantee that if you increase the priority, it will get executed first. As I told you, you can just, request. That's all, and that's how I am going to show you. It's not guaranteed that it will print that one only. Now, what you can do is here is printer class thread t1 equals to new printer class. You can set the name as set name. I'll set t1. Okay, and let's create a few more. Okay, and t1 dot set priority. As you can see here, there is a method as a set priority, and the value it ranges from a min priority to the max priority. And these values, if you see here, min priority to, so let me check it. Priority, you can say min thread dot min priority. I don't know what is the value of this. Okay, so min priority is 1. Whenever you create a thread and you do not assign the priority, it's by default it's a 5, and all the threads will have 5, and there will be rush to get to that. And the maximum priority is 10. This is the maximum priority what you can give to a thread. So as you can see here, I'm writing one thread first here, and I'm giving this thread priority as a minimum. I want it to start. And let's see here, we'll print the priority. So priority will be thread dot current thread dot get priority. We'll see that what priority it's running. So Same thing I can do. I'll give this guy as a normal priority. So this T2 dot set priority, then thread dot normal priority. So normal priority, even if you don't give, by default it's a normal priority, and here I will not give anything, so it should be the normal priority. So it should T3 should print as a 5 as well, because normal priority and default priority is the same. And I will give this T4 fellas to as a maximum priority, even though I am running it there at the end of the all. So that's not fair, but T4, T3, T2. So T2, 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 T3, T3, then T3 dot start. Here T2 dot start, then T4 dot set priority. Sorry. Thread max. Instead of this, you can directly provide the value 10 also. There is no problem with that. T4 it is. T4 dot start. Okay, great. So I have 4 threads, right? And generally it should have been printing the T1 first, as I'm writing this first. Then this, then this, then this. If you don't use thread, you will see that it will always be in order, but it's as a thread. Now, thread scheduler is not guaranteed. Let's see the magic, what happens. Absolutely what we are not expecting. Illegal thread exceptions. Hello there. What is causing that? Oh my god. I'm running same thread again. Yeah. The priority, even though priority is 1, thread scheduler, it doesn't matter, but at least it's improved that T4 got the chance before this T3 and T2 got the chance. As you can see, both have the priority as a 5 and this guy has a priority as a 10, but it's not fair. T1 is getting chance every time first. That's what I was telling. It's not guaranteed. You can request. It's mood of thread scheduler, and we can just pray that okay, it should get done. So never rely on that. It's just feel convinced yourself that okay, I'm giving the max priority to this one. There is a one utility of this. I mean, one usage of this is that suppose there are many high priority threads you have created, and there is a very low priority thread you have created, and what happens, right? Thread schedulers keep giving the chances to maximum priority threads, right? So it can lead to the starvation of the low priority thread. It's just like a poor people and rich people, right? And there is a queue to go to heaven or somewhere, right? And there it will be something like whoever has the more money, they'll go to the directly heaven, or something like very big car, or some kind of very good place, or something like the good facility or something. What will happen to the poor people, right? They don't have the enough money to go into that, and they will always end up either losing the chance to go to there, right, that place. So the thread schedulers these days are designed to handle that. Okay, even if they will keep checking that whoever is the lowest priority, right, they'll keep in the, so it's becoming more and more intelligent, I would say. Just like yeah, so it's like becoming more and more intelligent. So there is still there are many research going on in big labs, and where to find out the fair chances to give to all the threads, and still they are not able to find out the perfect algorithms to deal with these situations. These things you can do, these things you can request, but it's not guaranteed, and that is the reason that even with the priority least priority, it is executing as the first. There has been some modifications and all these things, right? Because there are many starvation cases were coming, that where one thread has never run. I mean, it's already keep on getting executed, and other threads were starved. Okay, so to deal with such situations, these kind of algorithms has been come to the place. Fine. So this is about priorities. We'll go to the yeah, there are few other things you can do. What I will show you here is, suppose I have a class. Let's join example. Okay, even if you do not write a threaded program, Java application is a threaded program, and by default, if I simply write here thread dot current thread dot get name, it will print. It's a simple program, right? Java join example with main method. I'm simply printing the current thread, and you might be wondering, there is no thread, how come it will print anything, right? It will print as a main. So I hope everyone know that. Okay, so every program, even if you are not using threading, right, multi-threading, there is one thread which runs, and that is the main thread. So main thread is also a kind of thread only. So whenever you run your program, the main thread runs, and whatever the line of code it has written here, okay, print here and do all these call and all these things, right? After that, that thread dies. After that, there is no thread remains. So there are situations where you want something like this, and the problem what it will come to here is, suppose you have a thread class, class A extends thread. Oh, man. I'm running thread dot current thread dot get name. Okay, just simple. Void run is there, and it's simply saying I am running, and running, printing some stuff, and okay, so it's doing all these things. Okay, now what actually I want is, I'll create 10 threads. Threads. A equals to new A. Okay, and A dot start. After that, once it finishes, I am done. This guy is nothing but the main thread. So this I am done will be printed by the main thread, and let's see what actually problem happens here is, I am running, printing some stuff by thread 0, thread 4, printing some stuff is fine. After this, as you can see here, I am done has appeared, and main method is died. Okay, and then these things are still executing, right? Other threads are executing. So it is just like another thread. Main is also a thread, and suppose you want something like that, until unless it finishes these programs, finish these things, right? Do not execute this line. This is generally what happens, right? You write a code and you expect when these things finishes off, then only you print this one, I am done, right? It's not done, right? The work of main is still not done because it hasn't finished this printing all these things. Let me just comment out, it's becoming too much. So as you can see here, I am done here. It is printing before this guy has stopped printing. As you can see here, it's always doing one time. If I increase this value to 40, maybe it will end up well before than that. So see here, I am done. It is printing before though so many threads are still running and that guy has done already, right? I do not want to do that. I want that, okay, once all these thread finishes off, then only this should be executed, and then only you proceed. Something like, I would say, suppose your application has something like your database should come up first, your cache should come up second, your other web application should come up then you need to do other things, that okay, then you start taking the request. And if you are doing something like that before these thread comes live, this your system comes live, right? So which is not a problem, that is a big problem, I think. Sorry. So like, just you're booking a ticket, right? So you go and browse the ticket, like wherever the available tickets are there, and before you book on the ticket, the database should be up and running. So if that database is not up and running, if you click on book, it might give you error that okay, database is not available and all these things, right? Which creates a bad impression on the user, that okay, I mean, what kind of website, I mean, these people. And suppose the website page itself does not come, right? And it says something like, okay, we are bringing up the application, or application is booting up. So that thing is like, waiting for the other things to complete, and once it completes, then only you come up. So I want to show something like, I am done, okay, and ready to take request. Okay, so these things should be finished, and then only it should print, I am ready to done. I mean, it's way before it is telling, right, I am done, and not way before, at least 2-3 threads, right? So your services are not up and you are telling, okay, I am done. So it's totally not correct. So it's something like, I would say, the string, I'll give you more this type, service type, and so it's telling something like, suppose one has a cache service, one has a DB service or something like that. So while creating the thread, what you are telling is, it's something like a DB service one. So you can create something like, if I am creating a this way, so it's not, I want to be able to give the name. So suppose this is cache service, it should come up, and okay, so this is cache, this is DB, this is something like, I would say, web service, this is some like some other server, some other server 2, or something like that. You can have such scenarios where it needs to be done such a way. Yeah, so these things are up, and then you say that okay, all services are up and running, showing UI now. Okay, so that kind of situations you want, right? Oh my god, what is happening? All services up and running, it is showing, oh, t1 dot start t2 dot start. Okay, so yeah, so see, all services are up and running. Before it would have printed these things, right? It is telling that I am up and running, though it's telling a lie, right? And it's not correct. I want that, once all these things gets finishes up, right, bringing up this service and all, I want this to be at the end of the time every day, I mean every time. So there is a one thing what you can do is you can join that. You can tell that, okay, the main thread, you can attach the main thread to these threads to tell that once you finish, let me know, and the main thread will keep on count that, okay, all these threads has finished, then only I will able to do that. So we'll write something like t1 dot join, t2 dot join, t3 dot join, t4 dot join. And suppose t5 is not necessary, I mean even if a second server comes up or not, suppose this is server 2 and the server 1 this is, and if either of these services is up, I am okay. So you can do, I'll just add those, yeah. So even if either of this is there, it's fine. So I'm not waiting for I will not wait for t5. So now it's like something like whether t5 is there or not, it doesn't matter, it can end up before also. So you can see the problem, right? It's showing at the end. So if I write t5 also, it will always be at the end. See, it will always be at the end, always. And if I remove all these three things, right, suppose t1 and t2 only, then it will be like always it will be after t1 and t2, but it can come before 3 4 5, but it will never be something like t1 and t2, it will end before, like that time it has ended before this one. So it will, you will see that it will right now it's coming at the end, that is fine. It can come in between if you run multiple times. Okay, it's really irritating. Yeah, see here, but you will see that first and second, it will never be before that. I hope you would be understanding the reason why, because I'm joining, I'm waiting for these two, but I'm not waiting for the others. So this is how you can use the join method to sequentially execute when to do and not to do. It's a very useful method. Okay, it's done for me today. Any questions, any doubt? Okay, okay, fine. See you tomorrow. Maybe I'll start SQL tomorrow, just a little bit, and then I'll start JDBC, that is Java database, how to connect to DB, how to get the data from database and all these things, right? So I'll cover that portion. Then we'll start, after that we'll start this JSP servlet, where we will be going to the web development, web applications and all. Okay, good. See you tomorrow. Bye bye.